So we're actually going back to the previous page to do those other problems. This is on adding and multiplying imaginary numbers. So we're not going to have that same situation where we have the i's to start out with. They're going to kind of come from the radicals. So looking at letter A, first off, I have negative the square root of 4. Now that negative is not in the radical, so there is no I that's produced from that part. So that's just negative 2. Then we're going to move on and do the square root of negative 25. So the square root of negative 25 is 5i. And then the next thing we're going to do is minus the square root of 25. So there's some little close things here to make sure you really know what you're doing. So this is minus 5. There is no negative in the radical. And lastly, we have plus the square root of negative 49. So that's going to be plus the square root of negative 49 is 7i. So now we kind of see those complex numbers. We have some real parts, we have some imaginary parts. Negative 2 minus 5 is negative 7. And then 5i plus 7i is 12i. Okay, so that's my final answer. So if you want to pause the video and try part B, which is the next part, a little trickier because not everything is a perfect square, but it's good to try it and then come back. So here I have, for the square root of negative 16, I have negative 4. Then negative the square root of negative 5. So I'm just going to write down the first negative. These two negatives do not cancel out because one's a negative 1 and one's a negative in a radical. So it's not like a negative 1 times a negative 1 situation. So here I need to take out the I from that negative 5, but the 5 is not a perfect square, so it stays in contrast to this 25 where I could take the square root and get 5. So the next part is negative 3, right? No negative in the radical. And then 180 you'd probably have to play around with, but I'll just do that for you now. The biggest perfect square that goes into 180 is 36. So I'm going to write plus the square root of negative 36 times the square root of 5, because 36 times 5 is 180. So this section here is going to become 6i radical 5. Now, in preparation for that, we're going to bring down all the other stuff. I'm going to write this one as 1i radical 5. Okay, just kind of in preparation for the fact that we are going to get an answer here where we're going to have to combine this 1i radical 5 and the 6i radical 5. Now the directions say put everything in simplest a plus bi form when necessary, which is going to also bring up something else. So here negative 4 minus 3 is negative 7. Okay, I'm going to put these two together now. Negative 1 plus 6 is positive 5i radical 5. Now if they want this in a plus bi form, I need to take that and write this as 5 radical 5i. And that's basically because they want an a plus bi form, so the I has to come last. So the next two, C and D, are multiplying with imaginary numbers. Now, it might be tempting to think that somewhere in here I need to do a distributive property, but I don't because there's no adding and subtracting in these. This is a monomial times a monomial, okay? So I'm just going to simplify each of them first. So here I have a negative sign, and then the square root of negative 9 is 3i. On the next one, I have a negative 7, and the square root of negative 100 is 10i. And I could have multiplied that negative 7 and the 10 together first, and maybe I will do that. So this is negative 70i. And this is another situation where you might be tempted to make those negatives cancel, right, from here and here, but remember that one's in a radical, one's out. So then if I multiply these together, I get positive 210. I times I is I squared. So we know because this is negative 1, we're going to end up with negative 210. Moving over to the next one, I have here, this is one of those little rules that's slightly different about imaginary numbers. You can't multiply what's inside the radicals together until the i's come out. Otherwise, you lose the i's, you don't get the right answer. So I'm going to write the first one as 4. I'm going to take out the square root of negative 1, so 4i radical 10. And secondly, this one I'm going to take out that square root of -1 6i radical 30. Now neither 10 or 30 had perfect squares in them. If they did, I might have simplified them first. So when I multiply, remember no distributing. This is no addition or subtraction and no addition or subtraction. So I'm just going to do 4 times 6 is 24. I times I is I squared. Square root of 10 times square root of 30 is square root of 300. So here I have a 24. I have a -1 from I squared. And 300 does break up into the perfect square, which is 100, and the leftover of 3. So now I have -24 times 10, square roots of 3. -24 times 10 is -240, square roots of 3. And just a side note about math, I know that there's like, a lot of this is just like PEMDAS, like up a notch because you have the imaginary numbers and you have to simplify the radicals, but doing stuff like this really solidifies your basic math skills too. Like when do I distribute, when do I not distribute, how do the radicals work? So this is really good for your basic operations. So we have one more on the next page. This one actually doesn't have any imaginary numbers in it, so it's just regular radicals. So there's a couple ways I can go about this. I'm actually going to simplify the square root of 12 first. It's going to take a little longer, but just showing you that you can simplify the radicals first. So this is negative radical 3. 3 times 2 times radical 3. So here I get negative radical 3 times 6 radical 3. So this is going to equal, this is -1, so -6 times the square root of 9. And I could also know that radical 3 times radical 3 is just 3, or radical times itself is that number. But ultimately, if I'm simplifying this way, I am going to get -18 when I make radical 9, 3. If I had went and just multiplied those radicals first, which is allowed because there isn't any negatives. Remember, if there's negatives in those radicals, you have to take out the I first before you start simplifying. I could have done -3 times the square root of 36. 3 times 12 is 36, which would be -3 times 6, which is -18. Now that's definitely faster. Sometimes if I multiply those radicals together, I get a really huge number and I don't know how to simplify the radicals. So it's kind of like, either way is fine. And it'll be different in different situations as to which one's faster.